So thank you. So we're looking at the reservoir from initial to the altered states, and that's just a big title, but it's just the same reservoir that you and I know. Rocks that have the capacity to hold hydrocarbon, that have some degree of porosity and permeability. So we just want to look at how does it happen, what we see today in the subsurface, on the surface, using different technologies and by studies. How does it happen that what we know from the onset has become what we see today in our data? So it's just a friendly session, and I will appreciate your inputs. It is not meant to be a lecture, but let's see how it goes. I like to really get feedback, and please feel free to share your views and also ask questions. Okay, so this is the outline. I'll go ahead and look at what the reservoir is very quickly. The concept, definition, and occurrences. Where do we find reservoirs for those who are interested in studying reservoirs? And then we will now start the story of how the reservoir begins from an initial state and how it evolves to what we know, what we see in our data today. And then maybe one or two ways it impacts our hydrocarbon prospectivity. Okay. So what is a reservoir? Okay, first off, before I go into reservoirs, for those who may not be familiar with this, I want to assume we're all subsurface scientists, we're familiar with it. But a reservoir is a kind of rock, basically. For those who are not familiar, a reservoir is just a kind of rock that has the capacity to hold hydrocarbon. There are other kind of rocks that may not be able to hold any fluid in them. So they are called non-reservoirs. So let's just go on. From the onset, a reservoir is actually driven from a French word, right? I think it's the way it's pronounced in French. I'm not French speaking, but it actually means to hold something that has the capacity to hold, a place where things are kept, temporarily. Basically, that's kind of the French origin of the word reservoir. So in English, it says it's a place where something valuable is kept. For us as subsurface scientists, our interest here is hydrocarbon, oil and gas, okay? So that's hydrocarbon. It's usually stored in a location, in a type of rock called reservoir. Some people who are not geologists or engineers may say it's sand, but we, on the technical side, we call it reservoir, we call it sandstone, we call it reservoir rock, okay? Because it has spaces in them that can keep hydrocarbon. Now, one thing to note is that reservoirs begin their journey from where they start. Where they start, I'm going to show you some quick clip, and then we will talk about it. A reservoir naturally doesn't, begin from where you see it. Whatever you're seeing today in your well log, in your core, in the outcrop, for those who are geologists, probably did not start in that location. It has moved from wherever it started, from wherever it was sourced by mediums such as wind, or water, or other physical means like landslide, like mudslide, like earthquakes, where you have movement of the plates. So these things cause the transportation of that original rock from where it was originally intact, where it was deposited from the onset, to the new location. So for those who are also, again, if you are a geoscientist, you may know that reservoir rocks can be either clastics, what we call clastic reservoirs. That is, if it is something that has broken off from somewhere and then transported to another location where it is now finally deposited or where it's finally laid, it's called a clastic reservoir. There are some other kinds called carbonates. Those are usually in place, in situ. But for us in Niger Delta Basin in Nigeria, we have dominance of clastic reservoirs. So this talk is primarily addressing clastic reservoir rocks. And then there are also some unconventional reservoirs where you have like shales that have been fractured, right, and have the capacity to now allow fluid to stay in them or pass through them. So those are unconventional reservoirs. And then very quickly, like I talked about hydrocarbons staying in reservoir rocks, we are focusing on clastic, in this case sandy rocks basically, or sandy reservoirs. Okay, so hydrocarbon has a potential to stay in these rocks because they have what we call pore spaces. Okay, in other words, they are porous and then they are permeable, meaning they allow fluids to flow through them. So porosity helps to keep it in place, while permeability allows the fluid to move from one part of the reservoir to the other. Okay, so this is just a quick introduction. And any configuration that allows hydrocarbon to stay within a reservoir rock is called a trap. Any arrangement, any geometry that allows this is called a trap. Okay.